Hi students, today I am going to start a new reagent, that is lithium aluminium hydride. So as you know, lithium aluminium hydride is commonly used as reducing agent, and in your competitive exams, especially in IIT mains as well as in NEET and also in IIT advanced level, examiner generally asked problem related to lithium aluminium hydride. So whenever you see a particular problem having lithium aluminium hydride, so you have to identify the role of lithium aluminium hydride, what it does. When it comes in a chemical reaction, you know the reactant, you have to find out the product. Sometimes the problem is in one step, that you have to find out the direct product, and in some cases in the series A gives B, B gives C, C reacts with lithium aluminium hydride, it gives D, identify D. So lithium aluminium hydride is good reducing agent and it is commonly used. So what it does, it reduces the following compound. When it reacts with aldehyde, it gives primary alcohol. When it reacts with ketone, it gives secondary alcohol. When it reacts with carboxylic acid, it gives primary alcohol. When it reacts with ester, it gives alcohol. When it reacts with acid halide, it gives primary alcohol. When it reacts with epoxide, that is alkene oxide or commonly known as oxirane, it gives primary alcohol as well as secondary alcohol. When it reacts with ester, it gives primary alcohol. When it reacts with cyanide, alkyl cyanide, it gives aldehyde or it also gives primary amine. When it reacts with alkyl group containing NO2 group, that is nitroalkane, it gives primary amine. But when it reacts with aryl group containing NO2 group, that is nitroaryl group like nitrobenzene, it gives AR-NH bond NH-AR. AR is aryl group like C6H5, C6H5CS2, these groups. When it reacts with AR-NHCOCS3, it gives product AR-NHCS2CS3. And also when it reacts with azide group like RN3, it gives RNH2. So we have discussed a series of reactant which gives product as reduced product, and then second one, it reduces carbonyl compound. When carbonyl compound reacts with lithium aluminium hydride, it is as reducing agent followed by hydrolysis, so you will get different following products. Like if you take CS3 CS2 4 times CHO, that is total number of carbon is 6, that is hexanal. When it reacts with lithium aluminium hydride in presence of ether as catalyst and it is hydrolyzed, so you will get CS3 CS2 4 times CS2OH. Like that, when it reacts with crotonaldehyde is common name, that is CS3 CS double bond CH CHO, so that is converted into crotonyl alcohol, that is CS3 CS double bond CH CS2OH. So the double bond remain unaffected, it doesn't reduced into CS2. So this reaction is very important, and specifically when you take aliphatic unsaturated aldehyde and aromatic unsaturated aldehyde. In case of unsaturated aliphatic aldehyde like crotonaldehyde, it gives crotonyl alcohol, while double bond remains unaffected and aldehyde group is converted into alcohol group. But if you take benzene ring containing CH double bond CH CHO, so here the entire group like CH bond CH2 is also converted into CH2. So in this case, aldehyde group as well as double bond is converted into, that is hydrogenated. So you will get benzene ring CH2OH. Then if you take ketone like CS3 CS2CO CS3, So you will get CS3, CS2, CHOH, CS3. So you will get secondary alcohol. Like that, if you take CS3CO, CO, CS2, C double bond O, that is having same compound having ketone group as well as ester group. So like CS3CO, CS2, COO, C2H5. So it gives CS3, CHOH, CH2, CH2OH. So that is the reduction of carbonyl compound. So here we have taken two series of compound. One is the general group like aldehyde, ketone, cyanide. Second, we have considered reaction of lithium aluminium hydride followed by hydrolysis of carbonyl group. And third one is reduction of acid and their derivatives. So when acid, like if you take palmitic acid, CS3, CS2, 14 times COH, in presence of lithium aluminium hydride, in presence of ether, followed by hydrolysis, so you will get citral alcohol, that is CS3, CS2, 14 times CS2OH. Then if you take crotonic acid, that is CS3, CH double bond CH, COOH, in presence of lithium aluminium hydride, in presence of ether and hydrolysis. So in this particular series, in the third type of reaction, I am going to consider the lithium aluminium hydride in presence of ether followed by hydrolysis. So you will get CS3, CH double bond CH, CS2OH. Then if you take beta alamine, that is CS3, NH2, CS2, COH, so you will get CS3, CS2, CS2, CS2OH. Like that, if you take acid halide, or particularly if you take ethanoyl chloride, CS3COCl, you will get CS3, CS2OH. Like if you take acid anhydride like CS3CO twice O, so you will get CS3, CS2OH. Like that, if you take CS3, CH double bond CH, C double bond O, single bond O, C2H5, so you will get CS3, CH double bond CH, CS2OH. Like that, if you take amide group like RCONH2 or RCONHR or RCONR2, so you will get RCH2NH2, that is primary amine. Then you will get RCH2NHR, and finally you will get RCH2NR2. And if you take aromatic amide group like benzene ring containing NHCOCH3, so you will get benzene ring containing NHCH2CH3. And also if you take secondary amines like benzene ring containing NCH2COCH3, so you will get benzene ring containing NCH2CH3. So you know, I have covered so many reactions, and in competitive exam you will find the problem of same type. But you know, if you go through the chapter wise, if you study the reaction chapter wise, then it is very difficult to remember these reactions. So only what you have to do, why repeatedly I try to convince you, you should not worry about the number of reactions. Only thing you have to focus what reagent is, what is the role of this particular reagent. So why I am trying to emphasis on this particular concept, because everywhere you know you have to learn so many reactions, a bundle of books, notebooks are given to you, you have to memorize. So it is very hectic for the student to memorize those reactions. They are a lot of pressures during the exam time. So be relaxed, try to relax yourself. You only find out, you have to understand it is science, it is not the art subject that you have to remember everything, you have to memorize everything. You have to do the things smartly, you have to identify it is a reagent. What reagent is, you have to find out the product, because once you know the role of reagent, you can find out the product. So what I realized when I was a student, I was preparing for UPSC exam. So chemistry was so vast subject, you can imagine the number of reactions for the civil service examination. So in that time I realized, because I always go through the same reagent everywhere, I find the same reagent in every chapter, different chapter. So I simplified this method and myself I invent this idea of the reagent, and it is the basic reagent what you generally find in all the chapters. In some of the books you will find some very specific reagent like Fenton's reagent, Brady's reagent, but those reagents are very rarely used. If you go through my lectures, what I have provided you in 3 to 4 lectures, and also I will give you some more lectures, so you can cover 90 to 95% reaction with the help of these reagents. So what is the next role of the reagent? When reduction of nitro compound, azide, nitrile and oximes are converted into primary amines. For example, if you take CS3, CS2, CH, NO2, CS3 in presence of lithium aluminium hydride, or if you take C6H5NH2 in presence of lithium aluminium hydride, so you will get the reduced product. Like that, if you take azide RN3 in presence of lithium aluminium hydride, you will get RNH2. Like if you take allyl carbonyl azide like CS2 double bond CH, CS2 CH 2 and 3, so you will get CS2 double bond CH, CS2 CH2 NH2. When oximes are used, you will get the reduced product like C6H5 twice C double bond NOH, so that is benzophenone oxime, so it is converted into diphenyl methylamine in presence of lithium aluminium hydride and ether. You will get C6H5 twice CH If you take cyanide R C triple bond N in presence of lithium aluminium hydride at minus 50 degrees Celsius, you will get RCH double bond NH, and then it gives RCHO. But if you don't use the lowest temperature, that is lower temperature below 0 degree, at room temperature RCN is converted into RCH double bond and Li, and that is converted into RCH2 NH2. And halide group is also converted into what? Halogen group is replaced by hydrogen atom, as it is a reducing agent. So if you take CS3 twice CH, CS2Br, so you will get CS3 thrice CH. Like that, if you take oxirane like CS3 CH bond CH, and one bond is attached with oxygen CS3, so you will get CS3 CS2 CHOS CS thrice. If you take alcohol ROH in presence of lithium aluminium hydride, so you will get RO whole 4 times Al minus and Li plus, and hydrogen gas is removed. If you take RNH2 in presence of lithium aluminium hydride, you will get RNH whole 4 times Al plus C and Li, Al minus and Li plus hydrogen gas. So just go through these reactions. I have covered almost, I think, 30 to 40 reactions in this particular part, but I have emphasis only on the 4 categories. So what you do, just pause the video, write the reaction, try to understand the concept, take some more example. At the place of R you can take C2H5, C3H7, C4H9, these groups you can take. And best of luck. In the next video I will give you some more information about other reducing agent, and then I will cover the oxidizing agent. If you have any doubt, you have any problem, just ask me, put a comment, or just write me. I will respond you, and just go through these concepts, because this time, first time I am giving this most important valuable concept on a public platform. Otherwise I use this concept for my student in the coaching classes and the private coaching classes, private classes, all that. So it is free of cost. Get benefited, and subscribe the video, share it, like it. That will motivate me to give you more and more information for your career, and that will be useful for your exams. Best of luck. Thanks.